Okay, this video is going to have 4 questions. It's going to have question number 53, number 65, and it's going to have number 39 and number 20. So the first 4 questions. You were told to find the value of x, and so when you look at this, you can see x is on each side of each triangle. So I'm going to look and see, do I have any other information that can help me to find x? And when I read the information, it tells me that they have the same perimeter. Well, I know to find perimeter, that means that we add all the sides. And so if they're telling me that they have the same, that means that the first triangle is equal to the second triangle. Now I'm just going to write an equation. When I showed you the information on my paper, I just wrote everything out. And what I did was I used parentheses just showing the grouping for the sides. And so I'm not sure if this piece may have confused you. And if it did, I'm going to clear that up now. Meaning that you do not have to have the parentheses. As a matter of fact, I didn't even have to write this out that same way. So for this video, I'm going to write it differently than what I had it on my paper. So remember when we used the algebra tiles and I was drawing circles around the groupings to show you that these were groupings. Now, if we're working an equation, and same as with the algebra tiles, well, I would have my first group, which is x plus 3. Then I would have my second group, which is x plus 3. I would have my third group, which is x plus 3. And if I line it up vertically, you can see it, that when I take my different groupings and line them up, I'm just going to add them. And remember, we can only add like terms. So I'm looking at all of my x's. I have 3 x's. Plus, and I'm looking at all of my like individual tiles. So I have a total of 9. So for the first triangle, the perimeter is 3x plus 9. Now I'm going to move on to the second triangle. I'm going to use a different color for it. So I have x plus 3. Then I have 2x minus 3. Then I have x. So remember, I'm adding them together because I have perimeter. So that gets me a total of 4 x's. But if you notice on my 3's, if these were algebra tiles, I would have 3 positives and 3 negatives. And so they zero each other out, meaning they just go away. They cancel out. So now I have my equation, and I need to combine like terms. If I'm trying to decide on which one do I use, I don't mess with the 9 because the 9 is just a standalone. And there is no other term that's standing by itself, meaning that it doesn't have any variable or any symbol with it. And so it's just a constant. However, if I look at my 3 and my 4, I have an x value. So that means I have to combine them. I'm going to move it to the left. Move it to the right. The 3x to the right. It doesn't matter which one you move because either way it goes, you're going to end up with the same answer. It's just that if you move the 4 over, you will have a negative 1x. So that means you have one more step to work out. And once I subtract the 3x from the 4x, I just have the 1x. This is my answer. Let's move on to the next question. Okay, so for the next question, you were told to solve. The first thing that I realized when I look at this is that I have distributive property. So that means I have to work that first. I'm going to rewrite everything. And then I'm going to distribute to the right. So 2/3 W. Over to the side, I'm going to go ahead and write 2/3 times negative 1/4 because I have to distribute that. I have to multiply it in its fractions. Remember fractions, we just multiply straight across. So numerator times numerator, which gets me 2. Denominator times denominator, which gets me 12. My fraction will be negative because I have a positive times a negative fraction. When I look at my fraction, it can be simplified. So I have negative 1/6. And I'm going to go and put that in my information. Once I do, Now I see that I have, and let me make that line a little bit better so you can see that's not multiplication but subtraction. When I look at it, I have 2/3 W minus 1/4 is equal to 2/3 W minus 1/6. Well, I can move either term, but if you're solving, you may be thinking, okay, I need to solve for the variable, so I don't want to mess with it. Okay, so, and that's fine. You don't have to mess with it. And in my instructions that I showed you, I did mess with it as far as the variable terms. But for this video, I'm going to show you that it doesn't matter which way you go, you're going to still get the same answer. So if I decide to add my fractions, I just have a little bit more work to do. Now, I know on this side it would cancel out, but on the other side, I have fractions. And I have a negative 1/4 plus 1/6. And I know to add fractions, I have to have a common denominator. And that's negative. Remember, we only subtract the numerators. And make sure we put it in its lowest form. So that means make my wall here. That means to the left, I have 2/3 W minus 1/12. And then on the other side, I would have 2/3 times W. Now, the only thing I can do is combine my variable terms. So I'm going to subtract 2/3 W and then subtract 2/3 W. When I do that, this cancels out. Now, on the other side, remember I have an equation. So I'm going to write my equal sign. On the other side, this too cancels out, meaning that it subtracts. So I would have to put 0 because I just can't have anything there. And that's okay if you did just put anything there. Or didn't put anything there. You would notice that you would just have negative 1/12. But to the right, nothing is there. So for that reason, nothing just means it's 0. Now remember, we have an equation. We said that one side is equal to the other side. Once you work it out to this point, you can see that it's not equal. And for that reason, there is no solution. So it's no solutions. And we call this a contradiction. You may want to look at your foldable that should be in your composition book with identity and contradiction just to review this concept. Now let's move to the next question. Okay, so for the next question, it told us to solve for the variable, and so the variable we're solving for is A. I am going to rewrite this because it is small, and I'm solving for A. And so since I'm solving for A, if you want, you could just box the A. You can box the whole area that's with it. But for me, I'm just going to box A just so that I know that, okay, you know what? A is what I need to get to stand by itself. And so now that means I'm going to mess with everything that is on the same side as A. And remember, sometimes you may have to actually move the variable. But in this case, we don't. So this piece here, anytime I'm adding or subtracting something that is away from my variable, that is where I would begin. So I'm going to add 3/4 times B, and I'm going to do it on both sides. Now that I've done that, I know to the left, it zeroes out, leaving me with just 2/5 times A is equal to C plus 3/4 times B. Now, to get 2/5 away from A because I'm multiplying, I'm going to multiply by the reciprocal to get rid of that fraction. By doing that, 5 times 2 is 10, 2 times 5 is 10, 10 goes into 10 one time. And what that does is it gets me 1/8. A. I don't write the 1, and the only reason why is because anything times 1 is going to be itself. So there's no need in us writing the 1, but we always know that it's there. I need to also multiply that 5 over 2 to the other side. Now, when I multiply the 5 over 2 to the other side, I cannot just multiply it times the second term. Remember, when I move it over, I'm going to have to multiply each term by that. So you could have had 5 over 2 on this side as well. And that would make it a true statement. But remember, we're working with distributive property, and we have to simplify until we have nothing else that can be done. So if we leave it like that, you're not finished. So what I'm going to do is write my problem that was over here, and I'm going to group it, because now when I group it, if I put 5 over 2, I have the same problem as up above, meaning that this piece with the distributive property is the same as the top piece. But remember, if it's showing distributive property, we have to combine those like terms. So our answer is here. Let me know if you have any questions still on this process. Okay, so this is the last question that we have for this video, I should say. On the first day of the year, Diego had $700 in his savings account and started spending $35 a week. So we know that he had $700 in his savings account and he started spending $35 a week. Spending means subtracting, and then we have his brother, Juan, who had $450 and started saving $15 a week. And so our question, more or less, is after how many weeks will the brothers have the same amount? So we're looking for the same amount, and we need to also state what that amount would be. So let me write the first one for Diego. And I know that we can solve this many different ways. And as a matter of fact, when I looked at your papers, many of you did, and that is okay. I'm going to teach you, though, that you need to always write an equation or an inequality whenever we can write something, because we're in algebra, and that is one of the things that we need to master. So I know Diego had $700. He spent $35 a week, meaning that is my variable. His brother, so I'm going to equal it because it told me that they want the same amount. So if you're looking for those terms that help you to understand, okay, when do I put the equal sign? Well, it told you that they had the same amount. Just like on the perimeter question, it told you they had the same perimeter. So we know that one is going to be equal to the other. And so now I have one. And one is $450, and he started saving. So that means that he added to his, unlike his brother. Now, I have my equation written. I just need to combine like terms. When I showed you on my paper, I moved the variable terms first. But in this case, I'm going to show you that it doesn't matter where you begin. As long as you are combining like terms, you will get the same answer. So I have my constant terms, and then I have my variable terms. They have the same variable, and so I can combine them together. But again, I'm going to move my constant terms first. So I'm going to move the 450 over because I'm talking about money, and I don't want to be negative unless I have to be. So I'm going to cancel that out. And to this side, I have 250 minus 35W is equal to, and the only thing left to the right now on one side is 15W. Going to combine those, so I'm going to add the 35 to both sides. When I do that, this piece zeroed out, so that left me with 250 to the left, and on the right I have 50W. I'm not done because I need to find W, so that means I'm going to divide both sides by 50. And when you do that, and just quickly, I see this cancels out. I'm left with W. My zeros cancel out, so I'm left with 5 weeks. So I know that it was 5 weeks for them to have the same amount. Now I'm being asked, what is that amount? Well, the only thing you have to do is just rewrite your equation. And I'm aware that some of you put this in the calculator, and that is okay. But rewrite your equation, but this time put in your variable term. I didn't put enough room, so let me rewrite this. So now that I rewrote it, I'm just going to work it according to the order of operations. So I'm working multiplication first on both sides. And I'm going to stop the video as far as just, I'm going to work it, and then you'll see the end results with my steps, and you can see what I did. Okay, so once we did that, you can see that both sides is 525. So that means that the amount was $525 is what they had. Now, again, I know some of you use a table. Some of you work them out just individually, and it doesn't matter to me which way you did it, but I really would like for you to practice writing that equation. Let me know again if you have any questions. See you guys for tutoring Monday morning.